Hello dear students, welcome to the session on digital electronics and number system. Let's begin the new concept. So first of all, what is the digital electronics? Digital electronics is the study of electronic circuits that process and control the digital signals which are represented by binary codes, either it is a 0 or it is a 1. The digital signals represents the data using the discrete values, typically in the binary format. The binary format in the sense of either it is a 0 or it is a 1. Binary value 1 represents the positive value, that means a true, and the 0 represents a negative value, that means a false. So this is the definition of and what is the digital electronics. So digital electronic, it processes the discrete signals, information represented as in the distinct values, typically either it is a 0 or it is a 1. Unlike analog signals, that varies continuously, but the digital signals have only the two states, either it is 1 or the 0. 1 indicates the on, true, high, or 0 indicates the off, false, and the low values. So these two are the binary logic, that means a 0 or 1. So already I told that the binary 1 represents the positive value, true value, or on or the high, and the binary value 0, it represents the negative value, false, off, or the low. So then, what is integrated circuits? So integrated circuit, it is also known as the microchip. This microchip packs the millions of electronic components onto a single tiny chip. So this is a definition of this IC chip. We can also known as integrated circuits. So IC chip is a small electronic circuit that contains the many electronic components like transistors, resistors, and the capacitors on a single chip. In other words, an integrated circuit is an assembly of the electronic components in which hundreds to millions of transistors, resistors, and the capacitors are integrated and built upon to form a single chip. This is the definition of this integrated circuits. So these are all the scale of the integration. So some in the initial days, so integrated circuits as in a simple circuit which having only the hundreds of the components, that is 10 to 100 components on the single chip. So in the modern processor, it has a millions of transistors on a single chip. In the advanced technology, so nowadays the today's processor contains the billions of components on the single chip. Let's begin the understanding of the number system. So what is a number system? A number system is a method of representing the numbers using some specific symbols or rules. A number system is a method of representing the numbers using some symbols for both mathematical and also the computer science. So these are all the number systems which are used for communicating. The computers and humans uses some different number system to represent and process the numerical information. The number system has mainly classified into the two different types. One is called non-positional number system. One more is positional number system. Non-positional number system consists of different symbols used to represent the numbers. It's like the Roman number system. This is the examples for non-positional number system. Roman number is an example for the non-positional number system. Then the second one, the positional number system. A positional number system is a system where the value of a digit depends on its positions within the number. Some examples for the positional number systems are decimal, binary, octal, and the hexadecimal number system. So these are all examples for this, the positional number system. So this is an example for this, the non-positional number system. In Roman number, The each symbol has a fixed value regardless of where it is appears. So I represents 1, which is always the 1. So V represents a 5, X represents a 10, L represents the 50 number. So these are all examples for the positional number system. In the position matters, the same digit has a different values based on its positions. So common examples are the decimal number system has a base 10, binary number system has a base 2, octal number system has a base 8, hexadecimal number system has the base 16. So this is the definition of what is a base or a radix. The base or radix of a number system is a number system that has the total number of digits present in that one. That means the base or a radix of a number system is the total number of digits present in that number system. So for example is a decimal. Decimal has a base 10 because it has a 10 digits starts from the 0 to 9, so that the total number of digits in this decimal number system has a 10, so its base has a 10. Second is a binary. Its base is 2 because it has only the 2 digits, either it is a 0 or it is a 1. So its base or radix it is a 2. So same as like that, octal number system has a base 8 because that has only the 8 values starts from the 0 to 7. Same as like that, the hexadecimal number system, the base 16 because the hexadecimal number system, the total number of digits are 16, starts from the 0 to 15. So thank you. If you have any doubts about this concept, please contact the email address provided in the below description box. Thank you so much.